This video is about domain, and so when we have particular functions, we have to know what the domain is, meaning what are all the possible x values we can have for a particular function. So in this video we're going to focus on three different kinds. We're going to focus on polynomial functions, rational functions, and radical functions. Okay, so we'll kind of walk through each one here. So we'll start with polynomial functions. So polynomial functions. So a example of that would be if I had f of x equals, let's say, and there's double parentheses, sorry about that, there we go, equals 2x cubed plus 2x minus 5. Right, so polynomial means multiple terms, all right? And so if I were to graph this, again, I have really honestly no idea, but just from general knowledge of math, if you type it in on Desmos or something like that, it should look something like this. Again, just totally making it up, no big deal. Okay, so if this what a polynomial graph looks like, right, and the square would be a parabola to the fourth power, fifth power, it just has more turns and twists. But the idea is the domain, right? So the domain is the x-axis. Look at how the graph is going, right? So you notice how the graph is going down and out, and if I just let it go on forever, it would just keep going to the left, correct? It would never stop. Same thing with this end of the graph. If I let it just keep going up, it's also going up and out, and it's never going to stop going up and out. So the domain for any polynomial function is something that, I mean, you hear it all the time. So the domain for all polynomial functions is going to be all reals, is the way they say that. Okay, so the domain for this is all reals. But that's how you say it, but how do you write it? So there's a notation called function, or excuse me, interval notation. Interval notation has different set of things here. So we have parentheses or we have brackets, okay? So parentheses in this case means we do not include that value. So do not include value. And the bracket means we can include value. All right, so again, and obviously we can do the other parenthesis too. We can close it and then close it if we want to, something like that. Okay, so parentheses means I can't include, and the brackets mean I can. And just to kind of look at it, so if I look at the bracket and complete it, see how it makes the letter I means I can include. Anyway, just a different way to look at it. All right, so for this graph, all reals, the way we'd write that is, it can go as low as negative infinity, and it will go up to positive infinity. When it's interval notation, we write the lowest the graph can go, comma, the highest the graph can go. Now, as far as infinities go, we have to put either a bracket or parenthesis on either side. And for all infinities, if you want to write a little note, we can't include it, right? Because negative infinity isn't an actual number. It's a concept or an idea. Because if we say, oh, negative infinity is negative a million. Well, couldn't I think a number smaller than negative a million and 1? And we could keep playing that game, or just say we can't include it because we actually don't have a value for it. Same thing with positive infinity. So we put parentheses on the infinities. So even if it's not a polynomial function, for another graph, if it's at negative infinity or the domain stops at positive infinity, we always put brackets around, parentheses around infinities. Okay, so for polynomial functions, the domain is all reals, and this is how you write it in interval notation. All right, the next kind we have is radical functions. Okay, and yes, they are awesome. Let's just go ahead and get that out there. But what I mean by radical is the equation is inside a radical. All right, so let's say it was g of x equals square root of x plus 3. All right. And again, if you know this particular graph, it's a square root graph. And if I were just to draw a rough picture here, it would actually be here and then just kind of arch out this way, right? So one thing about radical functions, as I'm sure you guys know, especially if it's an even root, so even though it's not written, there's invisible 2 here. If it's an even root, I can't have negatives under the radical, correct? Because if I had a negative under the radical, it becomes imaginary, which means I can't graph it on a normal coordinate axis, okay? So, because, for example, if I were to plug in negative 4 for x, okay, I'll just make a simple xy chart here, just to kind of explain the point. If I were to plug in negative 4, So that would be negative 4 plus 3, which gives me negative 1 to the radical, which again, I would have to change that negative to an I, and that would be I radical 1. But again, it's imaginary. So I can't graph it because it's an imaginary number. Okay? But if I plugged in negative 3, for example, negative 3 plus 3 is 0. Square root of 0 is 0. 0 is okay. 0 can be under the radical. We're fine with that. All right. If I plugged in negative 2, that would give me the square root of 1, which is 1. So the only issue I have is this cutoff point right here. At negative 3, I'm okay, but at negative 4 and something smaller, like if I plugged in negative 5, I'm going to get imaginary answers, which I can't have. So how do I write the domain for this particular function? Now, I drew the picture, and some of you might say, well, duh, like, it's pretty obvious right there. But let's say you didn't have to draw the picture. What would be the domain? Okay? So, we need, right, so we only want the positives, correct? Because if there's a negative under the radical, it can't be solved. So the way we write this would be, the square root of x plus 3 has to be greater than or equal to 0. And so we solve this equation, and it will tell us what the domain is. Okay, so this is how we solve for the domain. Okay, so to get rid of a square root, we square both sides, which that gives me x plus 3 is greater than or equal to 0. Because 0 squared is 0. Subtract 3. And that would give me x is greater than or equal to negative 3. So, x has to be greater than or equal to negative 3, which again our xy chart kind of confirms for us. But if it has to be greater than negative 3, the way I would write that in interval notation would be, so the lowest it can be is negative 3, right? Because if it has to be greater than or equal to negative 3, it can be negative 3 comma, and this is going to go to positive infinity. We talked about it on the last slide here. This has to be a parenthesis. We can never include infinity. But what about the negative 3? Notice how if I plugged in 3, or excuse me, if I plugged in negative 3, I get 0. 0 is fine for a radical function. We're okay with 0. But it can't be less than 3, right? It can't be less than negative 3. But I can include it, so that's why I'm going to put a bracket around negative 3. Okay? So, we talked about polynomials, we talked about radical. One other example here I want to do, let's talk about if it's an odd. So if I did like h of x equals the cube root of x plus 3. Okay, so cube roots are any odd root, so it could be a fifth root, a seventh root, this is the third root or a cube root. Okay, if I were to plug in a value, I can actually have negatives with cube roots. Like, so if I had the cube root of negative 8, okay, or I would say it was negative 8. I can actually, because how do I get negative 8? Wouldn't that be negative 2 times 2 times 2, right? That's how I can get negative 8. So, the fact that I can include a negative in there, or if I actually make all three of them negative, negative 2 times negative 2 times negative 2 equals negative 8. So, with odd radicals, so third power, fifth power, seventh power, or excuse me, third root, fifth root, seventh root, I can actually have negatives and that's fine. So for all odd radicals, it's all real numbers. Or, again, the way we write that in interval notation, negative infinity to positive infinity. Okay, so that's how that process works. All right, so the way that happens is if it's an even root, like a square root function, or again, any even root, you actually have to make sure to set whatever it is greater or equal to 0, and that will tell you your domain, and this is how you write an interval notation. And then with any odd root, again, you don't even have to do the work. You can just say, oh, I know it's going to be negative infinity, positive infinity, or all real numbers. All right, the last kind that we have here is a rational function. So a rational function. And that rational, again, that's just in mathematics, it's a fancy way of saying a fraction. Okay, so if I had q of x equal to, let's say, x plus 3, x minus 2, right? So two different polynomial statements on top of each other, making a rational function. In this scenario, the only thing that concerns me about the domain is my denominator, right? Because in a fraction, hopefully you remember from your years of school, I can never divide by 0, or I can never have 0 in the denominator. If I have 0 in the denominator, that makes the function undefined, meaning my answer for x can't be that. So we want to find out what makes my denominator 0. So what we do is we take the denominator, which in this case is x minus 2, and set it equal to 0. Because we're going to find the spots, or the gaps, or the holes, where the graph is, and we're going to find out where it equals 0. So if I add 2, x equals 2. So this is the one spot, so this one's kind of weird to think about. This answer is the one spot I can't have my domain. So it can be everything except for 2. So the way we'd write that would be, that means it could start at negative infinity, go to 2. And remember, can I include 2? Right? If it can't be 2, I can't include it, so I'm going to put a parenthesis. And then we actually have to pick up a second interval, because it can start back up at 2 and go to positive infinity. But notice how I put parentheses on the 2, because remember, parentheses mean I don't include that value in the domain. I can stop there, but the parenthesis means I do not include it. Okay? So that's how you do that problem. Just another quick example of a rational function. Let's make it t of x equals, let's say I had like x squared plus 2x plus 3 over x squared plus 10x plus 9. Okay? So if I have this, again, if I'm only looking for a domain, I'm not asking the graph or solve anything, I just want to know where the domain should be for this graph. So in a rational function, always think I can never divide by 0. So let me find those spots, and then I can make sure to exclude them from my domain. And so this is just regular solving quadratics. So you guys should hopefully know how to do this. We'll do x factor chart because that's our favorite. 9 up on top, 10 on the bottom. I believe 9 times 1 gives me 9, but 9 plus 1 gives me 10. Okay? So, and a is positive 1. Perfect. I can go straight to my factors. X plus 9. X plus 1. Which means my values are x equals negative 9 and x equals negative 1. So those are my two spots where my domain cannot be. Okay? So anything less than negative 9 is fine. So negative infinity to negative 9. And remember, I can't include it. And again, we can say, oh, well, starting at negative 1 to positive infinity, correct? But what about the space in between? Right? What about the space between negative 9 and positive 1? Is that okay? Yes, it is. We actually can include the space in between negative 9 and negative 1. But again, notice I put parentheses around it because I do not include those values, because that would give me a 0 in the denominator. Put U's in between them, and that is my interval. There's 3 pieces to this interval. Okay? So that is how you find the domain for those 3 types of functions: a polynomial function, a radical function, and a rational function. I hope this is helpful. There you go.